Hello everyone, welcome back. So in this video, we are going to understand the problem number 3074 and we'll understand how to implement it. Okay. So very first, the question is saying that Apple redistribution into boxes. Okay. Very first two things we have given, right? The two things is like, suppose we have given in the array integers. So two array integers we have given Apple and capacity. So what Apple at I we have here is number of minimum Apple we have in the ith, we can say that file, and the capacity we have given is the number of apples in the jth box, we can say that is holding. So ith and jth we can say we have here. Okay, means elements we have given in the apple is apples array, and these are the capacity, we can say the minimum maximum capacity or maximum apple capacity we can store at each index we have given like this. Okay, so let's try to understand very first. This is we have given apple means 1, 3 and 2. So if you talk about the apple one, right, apple, so these are the apples, number of apples we have given. Okay, so number of apples at index 0, number of apples at index 1, number of apples at index 2, like this we can say. But when we talk about the capacity, we have 4, 5, 1, 5 and another is 2. So capacity at this index 0 is 4, means maximum 4 apples we can store, or this capacity can be hold, right? Number of 5 apples can be hold at this position, number of 1 apple can be hold, like that we can say we have in this what you call the capacity. Okay, now understand then what is our goal, right? So our goal is very important. Okay, it is saying that return minimum number of boxes you need to select to redistribute n packs of apple into boxes, right? Means very first we can say we have to put all apples into where? Into boxes. Can we say that? We can say that, right? So each boxes, right, each boxes can be used at most how many times? One time, right? And a box can hold apples from the multiple piles. Let's suppose if I'll take the very first capacity, so capacity is 4, means this capacity can hold multiples apples. Let's suppose 1 and 4. Why? Because the question saying that it can hold, right? Right, capacity has capacity, right? And apples from the same pack can be distributed into different boxes. Okay, it means each box, right, each box can hold apples from different piles, you can say that. Okay, or multiple piles we can say. Okay, so we have to return the minimum number of boxes, how many boxes we have used. So we have to use minimum number of boxes needed. So in this explanation it is saying that let's suppose we have what, 1, 3 and 2 we have. So this number of apples we have, right? So these all apples we can store in where, if we'll take two what you call two boxes, 4 and 5 1, if we'll do the sum, we'll get how many apples it can store, 9, right? So it is saying we can store all these apples into here. So minimum boxes we need is 2. So these 2 boxes we need to returns to store, redistribute. So this is what the output is saying that. Okay, let me repeat you again. What are the things we have given? We have given 2 things, 2 integers we have given, apple and capacity we have given. So this apple stores number of apples at each piles, we can say piles is nothing but index, right? At each piles means number of apples stores, like 1 at index 0, 3 at index 0, 1, right, like that we can say. And each capacity holds, you can say, the number of piles, number of apples at the position, right? And what is our goal? We have to find, like we have to put all the apples into boxes, right? And so we have to return the number of boxes needed, right? And each boxes can be used at most once, only one time we will use, and its capacity can hold multiple piles from the multiple piles. Okay, this is what I'm saying. Means the box that we will use, let's suppose for capacity 4, we can use 1 and 2 1, right? Yeah, 1 or 3 1, or maybe more than that. Okay, 1 3 2 we can say that, but the capacity is not enough, right? So either 1 3, yeah, 1 2 we can store in the 4, right? We can say that. Then we need another capacity, we can say is 5, where the remaining one we can use. Let's suppose for if you are taking 1 2 here, so we can store what, 3 here, like that we can say that. Okay, what is important here to understand that it's very important, guys. Okay, understand. So we don't care which apple go into the boxes, right? As I told you just now that we will use these two boxes, right? So we don't care here which apples will go in these boxes or these boxes. It doesn't matter for us, right? Why? Because we only care about total apples. Total apples. Okay. And what will be the biggest boxes first? Two things you have to take care. Only these things, right? Total apple and the biggest boxes. How we can get? So total, what is the total box, total apples? 1 3 and 2, you will say is 5 and 6. We can say 6 apples we have. How we can find the maximum biggest boxes? Using 4 and 5 will get 9. We will say 2 boxes will, the biggest boxes we can get first is from using the box capacity 4 and 5 is the capacity having 9. So the biggest box we can say, and the total apple. So this is a greedy capacity coverage problem, not a very important topic, right? It's not like that. So we'll understand this. Okay, guys, understand what are the important things there? Total number of apples and the biggest boxes we need, right? Biggest boxes first we have to find. Okay, and the total apples. So make sure that this is not a this is a what you call the greedy, right? Greedy. This is a greedy problem, right? Greedy, you can say capacity coverage problem. Okay, greedy capacity coverage problem. Okay, guys, you can say that greedy capacity coverage problem, and it is not a matching problem, not a matching problem. Make sure that you are understanding, not a matching problem. Okay, this is what we have. Let's try to understand now. So think that we have given these examples, right? So very first step is to do what? Give me 1 second, guys. Let me clean first. So step 1, what we need to do, right? If we take these two things, let's suppose apple and capacity, very first step will say count total apples. Can we count it? We can count it, right? And that we have seen. How many count become? It became 6 that we have seen. Then in step 2, you have to sort the boxes. Sort the box with capacity, right? How will you do? And make sure that you do in the descending order. Okay, so now the capacity will be 5 4 3 and 1. This is the new array, right? And that is why we can choose these two, and we can say, okay, once we will choose these two, this is our what, the top 2 capacity is there, right? So what you can do, we know that these two things we will do. Okay, so what we can say, we need total how many sorry, guys, we know that how many total we need. Total we need apple is total apple needed is 6. We can say that. So very first, when we'll use this capacity one, that is called capacity 5, we can say. So 6 minus 5 equal to 1. This is our remaining apple, right? So how many box we need now? One more box is needed. So the box that we will use is, okay, use box is 1, that we have used this box. Now we need another box for the remaining one, right? So we need another box from here. So we'll say, okay, now the left one is remaining apple is 1, and the box that we have used is 1. What you can do, take another box. So another box will be used from here. So the count, use boxes count will be 1 2, right? And we'll say, okay, the remaining is how many left is here? 1 minus 4 equal to minus 3, which is covered. Already we have covered all the use apples. Remaining apples is completed now. So stop it. We don't need to do anything here, right? And so the answer become what? How many boxes we have used? 2. So these use boxes will become our answer. Okay, this is what we have to do, guys. So can we say that like, what is the intuition? What is the intuition? So intuition is to minimize the box count, right? So always use the largest box available first. This will ensure the maximum apples are consumed per box. Once total apples are connected, right, we can say, means total apples is used should be less than equal to 0, then we'll stop it. Okay, this is what we are going to do. So let's try to implement first. So very first, what I can do, okay, so let's continue to do from here. So very first, what we have given here, let's try to create a total apples. Total apples we can make is a 0. Then we'll say, okay, find the max, find the sum, total sum, right? So we can get each apple, we can get from where? The apple array, and we'll do the sum. And to do the sum, we know that we have created what? Total apple, and we just need to do plus plus all the apples, plus equal to a, we can say that. So we'll get all the apples here, right? Now we have all the apples. Now to sort the capacity, we'll say arrays dot, and we'll do the sort. Simple. So here we will pass capacity. Understand? This will sort the array into ascending order. Make sure that you know the things. So this is ascending order, means increasing order we have used here. Okay, then what we need to do, we will use the number of box that we will use. So we'll say, okay, int used box count. The box, yeah, used boxes, we can say, is equal to 0, we can say. So initially we have not taken any boxes, so now we will use the box count. So we'll start from for loop, and we'll say, okay, let's go with in the reverse order. So reverse, to get from the reverse order, what you need to do, we know that capacity is now in ascending order. So just do length minus 1, means from the last index, and I should be greater than equal to 0, means reverse order we are taking, and I minus minus. I hope there is no problem till now. Now total apples we have already found, means 6, we can say for now we have. So 6 minus the capacity, right? Can we say that? Capacity at I means 5. 6 minus 5 equal to 1. The remaining apple, total apple left is 1 now. So what we will do? Boxes that we have used, we'll say okay, find the boxes that we have used, we do plus plus. Now 0 to 1 it happened, next time it happened, so total apple left is 1, so we'll make another loop and we'll check the capacity. So this capacity will become what? 1 minus 4 is minus 3. So we have covered all of them. So we'll keep going until that, and then we'll return it. Return use boxes. I hope we understand. But if the total apples goes in minus, then what we will do, right? So in that case, we have to make a condition here. Is if our apple, which apple, total capacity of the apple, sorry, number of apple, if it is greater than 0, then will not go in this loop. The loop should be stopped. We just need one more condition here, right here. Or you can take total apples is greater than 0 in this condition, if condition, that will also work. Let me check. Okay, why and is not taking? Very first I, we have taken capacity dot length minus 1, then I should be greater than this, right? No, it should be not be there. Yes, so this will work, guys. Let me submit. Yes, so it's working fine. The code is submitted, working fine. Now what you can do is, let's suppose if you don't want to put here, right, you can make a if condition here and you can put this code inside the if conditions also. Okay, this is what we have done, guys. If you, in case if you have any suggestion, you can put me in the comment box and you can ask the question in the comment. Can you do one thing, that if you write the time and space complexity in the code, then that will be good for everyone. And if the time and space complexity is good, I'll give the heart into comment box. Thank you guys, thank you for watching this video, and see you in the next one.